Such is my devotion to the understanding, or your understanding, of mathematics, that while my wife is in the other room watching The Walking Dead season 6, if you've watched it, I'm in here in the study, and I'm about to talk about circular functions. So you would have seen trigonometry in the past, year 9, year 10, and what you would have operated on is right angled triangles. But have a look at this. I'm about to graph y equals sine x, and what they produce is these beautiful waveform graphs. So to get to this point here, I've got to teach you a few things. So that's what today and the next few lessons are all about, is just developing your fundamental skills with, what would you say, a bit of algebra, a bit of understanding of a unit circle, symmetry, things like that, to develop these graphs here. So let's get stuck into it. Okay, so the first thing you would maybe recall from the end of year 10 is that we actually did a little bit of work with the unit circle. Okay, so the unit circle has a radius of 1. So there it is there. All right, unit circle, there's the unit circle, radius there of 1. Center is at the origin, 0, 0. So there's the origin, 0, 0. And it has a circumference of 2 pi units. Now, why 2 pi? Well, if that's just a circle, remember circumference equals 2 times pi times the radius, 2 pi r. And the radius of the unit circle is 1. So that's circumference is 2 pi. All right, so now to get to that point with your calculator where we discuss what radians are. So you would have seen on your calculator this stuff here. I'll get rid of this stuff here, and note that I'm in what's called degrees mode here, okay? And for almost 98% of the work that we're going to do with trigonometric functions, you want to be in this mode here, rad, okay, radians mode, okay? So what are radians? So it's the angle made when the radius is wrapped around the circle, and it's defined as 1 radian, okay? So if I basically grabbed this radius here, this one here, and wrapped it around the circle, it would end up somewhere there, and it's roughly 57.2958 degrees. Now, why that number? It's a tricky concept and worth spending a little bit of time to understand. Okay, so 2 radians is the size of the angle formed at the center of the unit circle when the arc length on the circumference is 2. Okay, so there's 1 radian. Here's a second radian, which gets me to here, and a third radian, you can see, roughly gets me to here. Okay. And so what we know is that the distance from there to there is actually 180 degrees. So starting here, we'd open up 57, another 57, and another 57. And we can see here that this would be just a straight angle. So if we're in year 7, you'd say that that's 180 degrees. And what that would represent is, what distance is that? That's just pi, okay? And if we look at that, then what I could do is work out what 1 radian is. Okay, so I'd simply divide by pi and divide by pi. And what that means is, in this case, not equal, so I get pi over pi is 1 and 180 over pi. So let's try that on our calculator. Type in 180 over shift 0. And let's get an approximation on that, which is the value of 1 radian. Okay, so that's the same thing there, except I've used 2 pi as 360, which means pi is 180, 1 equals 180 over pi. So thus 1 radian is 180 over pi, or roughly 57 degrees. How many degrees is 2.5 radians? Okay, well, fairly easy to do the conversion. If we know that 1 radian, and we use that little c there to represent radians, we know that that's roughly or exactly 180 over pi. So 2.5 will be that multiplied by 2.5 and that multiplied by 2.5. So 2.5c, or radians, will be, what's 180 times 2.5? 360, 450 on pi. I'm not confident about that. That times 2.5. We'll force it to do the divide first. 450 over pi. There we go. Okay, so 2.5 radians is 450 over pi. Now I can approximate that reasonably well. So I know that 1 radian is going to be 57, 2 radians is going to be 114, half a radian is 25. So 114 and 25, 35, 45, well, roughly 149. Let's get an approximation on that. Just see. 143. All right, so I'm a bit out, but okay. All right. So two formulas will assist and are based on the idea that 2 pi is equal to 360. When we want to convert degrees to radians, what we do is we multiply by pi on 180. And when we want to convert radians to degrees, we multiply by 180 over pi. All right, so let's try it out. So if I've got 60 degrees, I want to convert that to radians. Okay, so what I'm going to do is note that that's going to be 60 multiplied by. Now, what are we doing? We're converting degrees to radians, so what we're going to do is multiply by pi on 180. All right, so that's going to be 60 pi on 180. That's once, that's 3 times. So it's going to be pi on 3 radians. Now, we don't have to write the C on that each time we use it. It's just assumed that we're going, when I write a value as pi on 3, I'm not talking about degrees. I'm talking about the measurement in radians. Okay. Okay, 150 degrees. Okay, so 150 multiplied by pi on 180 is going to be, what's that? That's going to go, let's chop the zeros off first, and then 15 and 18, that's 5 and 6, equals 5 pi on 6. All right, 225. All right, now see if you can start to sort of use your skills and think about the unit circle to work out what this might be. All right, now I'm going to try this one out. All right, now 225, here's 180, and here's 270. And 225 is simply in the middle of that. All right, now this would be 1/4 of the way around the unit circle, 2/4, 3/4, 4/4, 5/4. Okay, so this answer here, I believe, will be 5 pi on 4. Don't believe me? Let's try it out. 225 multiplied by pi on 180. All right, what are we going to do here? We're going to divide by 5. 8, 1, 8, 18, 225. Let's divide by 45. So 45, 90, that's 4. And that is, surprise, surprise, 5 times equals 5 pi on 4 when I divide through by 45. So we can do it via like looking at the unit circle and anticipating the result, or we can do it just by punching out the values using the formula. Okay. Now, can you see why the formula works? Okay. When we convert degrees to radians, what we do is we multiply by pi on 180. Okay. Now to do it, all you do is you establish the relationship. You go 2 pi is equal to 360. Okay. And depending on what you're converting, if you want to convert degrees to radians, we're going to go, all right, I'm going to multiply or divide this by 360 and divide this by 360. All right, that means that I've got 1 degree over this side here is the same as pi on, it goes once, that goes 180 times, equals pi on 180 radians. Okay, so if I wanted 2 degrees, okay, all I would do is just multiply this by 2, and that would be 2 pi on 180. 3 pi on 180, etc., etc. So here we want 60 of them, so it's 60 times pi on 180. That's how the formula works. Right, convert the following from radians to degrees. Okay, so again, if you forget the formula or sort of go, I'm not letting you use it, all you do is you establish the relationship between the degrees and radians by saying 2 pi is the same as 360. All right, and then what we're going to say is what I want to do, I want to convert to degrees. So I'm going to divide by 2 pi, divide by 2 pi, and that will cancel out, leaving 1. And that's going to be 180 on pi. So here I've got pi on 6, and what I'm going to do is multiply that by 180 over pi. All right, that goes once, and that goes 30 times. The pi's cancel out, and we're left with 30 degrees. So pi on 6 is 30 degrees. All right, now I know that one off by heart, and I'm going to show you how I know that one. Okay, so here's pi here, and what we're going to do is split pi into 6 separate parts. Okay, so here is 1 part, 2 parts, 3 parts, 4 parts, 5 parts, and 6 parts. All right, so what we're going to do is note that when I split pi into 6 parts, what are the degree measurements going to be? Okay, it's 180 all the way from 0 to pi. So what that will mean is that it's going to be 180 split 6 ways. So that's going to be 30 degrees, 60 degrees, 90 degrees, what's that? 120, 150, all the way down to 180. So there's 30 degrees, which should be pi split 6 ways, has to be pi on 6. So 60 would be 2 pi on 6, 90, 3 pi on 6, etc., etc. All right, so 3 pi on 2. Okay, so again, I've forgotten the formula. What way do I go? To establish the relationship, 2 pi is equal to 360. Then what do we want? We want radians to degrees. So I'm going to divide by 2 pi and divide by 2 pi. That's 1 equals 180. 180 on pi. So what I'm going to do is I've got 3 pi on 2 of them. So I'm going to multiply that by 180 on pi. Pi's cancel out. Once 90, 3 times 90 is 270 degrees. All right, last one. Multiply by 180 on pi. Cancel, cancel. Once, how many times can I stick 4 into 180? What's that, like 4, 2, 5? Is 9 times 45. And that is, so, it's going to be 225, I think. 9 times 40, 9 fours are, what have I done wrong here? Let's just do this. 9 fours, 36, 40. So that's 405 degrees. Now you might be thinking, how can you do that when you can only go 360 around a circle? That's fine. You can start at 0 and you can head in this direction here. So we're at pi on 2, pi, 3 pi on 2, 2 pi, and we just keep going around the circle, okay? So that indicates that I've gone 1 full revolution and then a little bit further, in fact, 45 degrees further than 360 there. All right, so you need to practice those skills, okay? So there are your questions that you need to do from 14A. All right, let's get stuck into 14B, which what we'll do now is define our circular functions, the sine and the cosine function, okay? So theta is the angle measured anti-clockwise from the x-axis. A negative angle is measured clockwise from the x-axis. All right. So what we're going to do is note that whenever I want you to move around the unit circle, okay, that if theta, the distance that I want to go, is positive, I want you to go in an anti-clockwise direction. Okay, if it's negative, I want you to go in a clockwise direction. It's a little bit counterintuitive. I don't know why it's anti-clockwise or why it was made this way. It's probably a really good reason. I just can't think of it at the moment. All right, the position of a point P on the circle can be described by relating the angle theta to the Cartesian coordinates x and y. The point P on the circle corresponding to an angle theta is written P theta, and the coordinates of P theta are cosine theta and sine theta. Okay, so let's have a look at this and see what we're talking about here. Now, this starting here, we want to open up an angle and get to this point on the unit circle. That's where we want to get to, right? Now, how would I describe where this is on the unit circle? Just say, I want you to meet me somewhere on the unit circle. So I'm like, all right, I'm standing here. How am I going to describe the coordinates on the Cartesian plane? Well, this value here is again just an ordered pair of an x and a y value. Now, how would I work out the x value? Remember, this is just a right angle triangle, and this is where this trigonometry starts to come in, okay, the year 9, year 10 trigonometry. This is a right angle triangle. All right, so let's have a look at the right angle triangle. I'll just pull it out. Now, what do we know about this right angle triangle? I know that that value is 1. Now, if I'm looking for this, this value here, let's call that one x, all right? What I'm going to do is note that to get this, given theta, is I would do the adjacent over the hypotenuse, okay? Remember back to SOHCAHTOA, okay? The relationship between side lengths for the particular trig functions, that's the sine, opposite, and hypotenuse. Cosine, adjacent, and hypotenuse, and tangent, the opposite and the adjacent. Right, so this is adjacent over the hypotenuse. Okay, so this one here is actually cosine. Okay, so what we note is this x coordinate here, okay, would be the measurement of that, i.e. how long that was, and that would be given to us by cosine. Now this y value, okay, let's have a look at that. We'll say that that's y, that's theta, and that's 1. That would be opposite over hypotenuse, and that's sine. Okay, so this y value, how high it is, okay, that measurement there, would be given to us by finding out what that one is there. Okay, so that's how we get those y values. So if you ever forget, all I do is I quickly sketch a unit circle, whack in the radius, which is 1, and go from there. Okay, and I just work out, how would I work out the y value? That's going to be the opposite over the hypotenuse. How would I work out the x value? Adjacent over the hypotenuse. Okay, now another easy way to remember, I don't like this one, but it's one way that you can use. So cosine is x, okay, and sine is y. Okay, now what am I saying there? So all you do is you list the trig functions alphabetically that we use. So cosine and sine, c comes before s, and x comes before y. Okay, so cosine is x, sine is y. Now note that if I'm at a point on the unit circle and I add 2 pi to this, then all I do is I end up back where I started. Okay, so it takes me to exactly the same place each time I go 2 pi around there. Again, I sort of always imagine it like running laps of Duncan McKinnon, and what I do is, I do 1 lap and end up at the same place, and then usually after a couple of laps of Duncan McKinnon, pretty quickly heading to my car to go home. Anyway, I digress. Okay, so cosine 2 pi plus theta is the same as cosine of theta. So if you add 2 pi to the angle, all you do is it's just the same as being at that angle. It's the same as sine. All right, let's start to check it out here. So let's do some examples here. So we want to get the sine of theta. Okay, so doing these problems involves a basic strategy. So the first strategy is drawing a unit circle. Okay, so you need to have a dodgy unit circle. So this is what I call a dodgy unit circle. Okay, now on that dodgy unit circle, we're going to note that we need to find out where we are on the unit circle. Now pi, where's pi? Here's 0 and here's 2 pi. So pi is half of 2 pi. So we'd actually be right here on the unit circle. All right, now what we do is we think about our value, okay, on the Cartesian plane, i.e. what would the coordinates be? Well, what's our x value? Our x value is over here. Now here's the origin on the unit circle. Over here is 1, and this value here is -1. So our x value will be -1. What's our y value? It's 0. Okay, now what do we want? We want the sine of pi. So the sine of pi is the y value. Okay, remember sine is given by the y value there. So the sine of it actually will be 0. So the sine of pi is equal to 0. Now you can test this out on the calculator. So what you want to do is make sure you're in radians mode, and then you're just simply going to go shift and, is it 1? Yes, it is. Shift 1 for sine and shift 0 for pi, and it will tell you it's 0. Noting that if you're in degrees mode, it's going to be a totally different answer, okay, because it thinks you're operating in degrees when you want to operate in radians, which is 2 completely different things. Okay, let's go to evaluate the cosine of pi. So the cosine of pi, well, remember cosine is x. Where are we on the unit circle? We're here. What we want to do is get the x value there. So that's going to be -1. Again, encourage you guys to try this out. Shift 2 is cosine, and shift 0 is pi, and I want to be in, obviously, radians mode, -1. Okay, this one here, we've got 3 pi on 2 in the negative direction. So here I am at 0, all right, and I want to go this way around the unit circle. So here's pi. So this value here, this would be pi on 2, all right? So this is pi on 2. This will be 2 pi on 2, which is just pi. Here is 3 pi on 2. So if I'm moving around in the negative direction, this is where I'm going to end up, okay? Now, what we're going to do now is work out what sine is. Sine is the y value. So we want the y value here. What's the value of y? Well, here's the origin, and here we've got an x value of 0, a y value of 1. So the sine of -3 pi on 2 is 1. And note that that negative sign doesn't say anything about whether the number is negative or positive, okay? All it says is, this is the direction I want you to go. I want you to go anti-clockwise and tell me what your coordinates are, in particular, the y value at that point. Okay, now let's work out the cosine of -pi on 2. So again, we're starting here. This is pi on 2, or half of pi. All right, so this is where I am. Now what I want to do is work out my coordinates there. My x value is 0, my y value is -1. What's cosine? Cosine wants the x value. So I want x there, and that is 0. All right, take a bit of practice, so be patient with yourself. Okay, we want the sine of 5 pi on 2. So where is 5 pi on 2? So I'm at 0. This is pi on 2, 2 pi on 2, 3 pi on 2, 4 pi on 2, or 5 pi on 2. All right, so this is where I am. Now, another way of thinking about this is the sine of 4 pi on 2 plus pi on 2. And that's the same as the sine of 2 pi plus pi on 2. So if I'm starting here and I want to meet you here at pi on 2, I could go straight to pi on 2, or I could go one full loop around and then meet you there as well, okay? And it'll end up being the same spot. So this is just the same as, we don't need to add this 2 pi because we end up at exactly the same spot. Let's just make this simple and work out the sine of pi on 2. All right, so the sine of pi on 2 is here. What's sine? Sine is the y value. That's the y value we want there. So that's going to equal 1. All right, now we want 7 pi on 2. All right, so what are we going to do? We're going to say that this is the same as sine of 6 pi on 2 plus another pi on 2. All right, that's the sine of 3 pi plus pi on 2. All right, now the way I do this is, see how that one there is what I call odd pi. This one here is what I call even pi. Now, odd pi will always start us here. Okay, this is going to be 3 pi, right? Because I go pi, 2 pi, 3 pi, 4 pi, 5 pi, odd pi, 6 pi, 7 pi, odd pi. So odd pi always starts us at pi, even pi always starts us at the origin, okay? That's what we did with this one here, 2 pi starts us at the origin. So there's 2 pi, 4 pi, 6 pi, 8 pi, 10 pi, etc., etc. So we're going odd pi, and then I want to go another pi on 2. Okay, so I'm going to go odd pi to there, and then another pi on 2. So this is where I am. All right, now I look at the trig function I'm working on, which is sine. Sine is the y value, that is going to be -1. All right, couple more to go. Sine of 9 pi on 2. All right, let's do that one. So I'm going to break this up by saying this is the same as 8 pi on 2 plus pi on 2. Okay, so what's 8 pi on 2? Sine of 4 pi plus pi on 2. Right, now again, this is even pi, so you could actually go around the unit circle. You could say pi, 2 pi, 3 pi, 4 pi, or you can just take it that even pi will always start us there, and then we're going to end up here at pi on 2. Right, so this is just the same as working out sine of pi on 2. We don't need to loop around 4 pi times or 2 lots of 2 pi times to do it. Right, so pi on 2, what trig function am I? I'm sine. Sine is the y value. This one here is 1. All right, the cosine of 27 pi. Now again, you can do this by going pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, but this is odd pi. Odd pi, I know, has to end up here, right? So this is going to be the same as saying the cosine of pi. Why go around 27 times when I can just go there, okay? Now, cosine of pi. Cosine is the x is -1, so that's -1. Right, so your job will be to do now 14b, as well as the worksheet, and really practice and hone these skills of navigating around the unit circle. Okay, the last thing I'm going to get you to do for homework is to just go back and review the trig ratios and have a bit of practice with them. So all 14D will be about is just giving you right angled triangles and a value. I don't know, I'll just say that's 37 degrees and that is 6, and we're after that length there, okay? And recall that what we'll be doing there is saying that opposite over adjacent, so tan of 37 equals opposite, which is 6 over x. X equals 6 over tan 37. X is equal to, and just whack that into your calculator for a couple of dp approximation. The only other one I'll just remind you about is just say that we're after an angle theta, where we've got this side here is 5 rather, and this side here of 2. Right, what would we do there? Okay, well remember, let's work out the relationship between the sides. This is the opposite and the hypotenuse. So this is the sine of theta equals 2 on 5. And then remember, what we do is to solve for theta, we find the inverse sine of both sides. So theta equals sine inverse 2 on 5. Theta equals, what's it going to be? Be pretty small, I'd say. 15 degrees as a guess. Right, so I'm going to go to keyboard, trig, and grab sine inverse and 2 over 5. Right, let's get an approximation on that. And it's really small. Okay, it's really small. Now I guessed it would be like 14 or 15 or something like that. And the answer says it's 0.41. And the reason for that is it's given us the measurement in radians. Okay, and because we're using degrees here, what we need to do is just whack the calc back into degrees and see what it says. All right, and that seems a lot more reasonable. Okay, 23, I guessed 15 or 14, but you know, it's not bad. Not a bad guess. So 23.57 degrees, dot, dot, dot. Now, don't forget, girls, to every time you're doing circular functions, you want to make sure you check your calcs in the right mode. Okay. Right, so your work will now be also to complete 14D.